Hello, my name is Tayfun, and in this lecture of our auxiliary course, you will learn about a lot of things about Linux command line. So let's get started. When you work in the Windows, Mac OS, and most other operating systems, you probably spend your time running applications like web browsers, word processors, spreadsheets, and games. A typical application is packed with features, everything that designers or their users would need. So most applications are self-sufficient. They don't rely on other applications, so you might copy and paste between applications from time to time, but for the most part they are separate. But the Linux command line is different. Instead of big applications with tons of features, Linux supplies thousands of small commands with very few features. The command cat, for example, for example, the print files on the screen, that's about it. So the ls file, ls command lists the file in a directory, mv renames files, and so on. So each command has a simple, fairly well-defined purpose. What if you need to do something more complicated? Don't worry. So Linux makes it easy to combine commands so their individual features work together as accomplish your goal. So this way of working yields a very different mindset about computing. Instead of asking which application should I launch to achieve some results, the question becomes which command should I combine? In this lecture, you will learn about how to arrange and run commands in different combinations to do what you need. To keep things simple, I will introduce just 6 Linux commands and their most basic uses, so you can focus on the more complex and interesting part about that, combining them without huge learning curve. So it's a bit like learning to cook with 6 ingredients, or learning carpentry with just a hammer and saw. So you will combine commands using pipes, and here this is a pipe here in Linux. So this is a Linux feature that connects the output of one command to the output of another. So let me open my driver here, gromit mpx here. So it takes one here. So if you have here, toggle painting, if you have one here, for example, this is our one result. If you make pipe between them like this will take here and put it here. So will be practical for daily use, so while others are just toy examples to demonstrate an important feature. So let's get started with input, output, and pipes in Linux here. Yes, actually, how can we clear screen, shift and home? Yes, clear screen here. So most Linux commands read input from keyboard, write output to the screen, or both. So Linux has fancy names for the reading and writing. For example, stdin here. So this is actually not a command, but just I want to talk about this. So this stdin is standard input or standard in. So this is a stream of input that Linux reads from your keyboard. So when you type any commands at a prompt, you are displaying data on stdin. And we also have the stdout pronounced as the standard output or standard out. So this is the stream of the output that Linux writes to your display. So when you run the ls command, for example, to print file names, the result appears on stdout. So now this comes the cool parts here. So you can connect the stdout of one command to the stdin of another. So the first command feeds the second. So let's begin with the familiar lsl command here. So lsl and bin here, for example. So as you can see here, the directory contains far more files. For example, if you have directory contains the more files than your display has lines, so the output quickly scrolls of the screen here. As you can see, it's shame that ls can't print the information on the screen full at a time. So pausing until you press a key to continue here, so like this. Or for example, slsm home, oops, home, and as you can see here, we got this. So let's actually also use the less here, for example, my file, and as you can see, we don't have a my file. So the less command displays a file on a screen full at a time. So you can connect these two commands because ls writes the std out and the less can read from the std in. So for example, lsl here, so let's clear, yeah, lsl here bin, and this is a pipe here, so use a pipe to send the output from ls to bin here. Oops, not like this here. So use a pipe to send output from ls to the input of less here. So in this case, the less is going to be less, and just that. And as you can see here, we got an screen here like this. Oops, here, right? Yeah, here, as you can see here. So the combined command displays the directory contents one screen full at a time here. So the vertical path here, vertical path that we've written here. Yes, here press return to quick here, or for example, let's lsl home like this, and as you can see here, we've written like the output here like this. So first command's std out to the next command std in. So any command line containing pipe is called pipeline. So command generally are not aware that they are part of a pipeline. So ls believes it's writing to the display when its fact output has been redirected to less here. So, and the less believes it's reading from the keyboard when it's actually reading from the output of ls. The word command has three different meanings in Linux. So the first is a command is just a program here. Just let's change my mouse. Yeah, command is just a program. So command is just a program. So this is an executable program named and executed by a single word, such as the ls here, ls, or a similar feature built into the shell, such as the cd here. Actually, let's say, yeah, ls, cd, cat, and goes like that. So we also, the command is also can be a similar command. So this is a program name or a shell built in, actually the simple here, simple. So this is a shell built in or optional followed by an argument, such as here the simple command is like ls, and here it calls the l here, and after that the, for example, home. So this is a simple command. And we also have a combined command. Combined command. So this is several simple commands treated as a unit in combined command here. So let's actually write something like that. So we have ls here. So after that it's l, and let's spin here, or home, and after that we are using the pipeline here, and then we are writing less. For example, this is a combined command. So why I'm telling combined is that, for example, here we are using a program. So we are using program here. So ls is a program, this is a program. Also the ls here is also program, but ls home is a simple command. So this is simple command, simple comment here. So also these two are the, what I said, the program. But here, all of these are a combined command. Oops, actually, let's delete that. Yeah, all of these are a combined command. So here it is the combined. This is all of this code here. The command here is a combined command. So in this course, I will use the word command in all these ways. So usually the surrounding context will make clear which one I mean, but if not, I will use one of the more specific terms in our next lectures here. So pipes are essential part of the Linux enterprise. So here, let's dive into building your piping skills with a small set of Linux commands. So no matter which one you encounter later, you will ready to combine them. So we will learn here let's actually draw this. So I will draw this here. So you will learn about firstly the WC. You will learn heat. You will learn heat here. So you will also learn cut. You will learn about the grep. You will learn sort, and here sort 1, 2, 3, 4, 5, and unique. And also, yeah, it's 6 here. Yeah, also ls here. So let's get started. So these commands have numerous options and modes of operations that I largely skip for now, just now, to focus on pipes. So to learn more about any command, run the man command here. Oops, why it's like that? Yeah, run the man command. Oops, yeah, run the man command like this. And for example, if I wanted to get an information about the ls, then the man command will give me a detailed description, the name, synopsis, description, and all of the information that I need here. Actually, we did learn this in previous lectures, but I just wanted to mention it again. So here, let's get started with the WC command. It's actually, yeah, here, clear, WC command. So the WC commands prints the number of lines, words, and characters in a file. So let's actually use for now, let's use the user interface for creating files, but in next lectures, you will also learn how to create, delete, and manipulate files from the command line. So here, let's create right click on it, create document, empty file, and let's name this file here Oxley create, and here delete this, don't save. Here let's increase the font size a little bit and write something here. So Oxley Academy, Typhoon, online Linux course, YouTube, we are on YouTube here, Oxley, and here this is our text for now, and we will use WC animals to print the number of lines, words, and characters in a file. So it's gonna be like Oxley, and here, as you can see here, we have 5 lines here and 83 characters, and we also have 5 words in these file lines here. So let's open what we have as a word. As you can see here, these, all of them, it counts as a word here. So let's add something with a space here and run this command again. As you can see here, we got 96 characters, 6 lines, 6 words, and 5 lines here. So WC reports that our Oxley has 5 lines, 6 words, 96 characters. So if you count the characters by I, including here spaces, types, and new lines, you will find 96 characters. So, but WC also includes the invisible new line character that ends each line. So the option here, WC here, for example, WC L, W, and C, instructs WC to print only the number of lines, words, and characters respectively. Here, if I wanted to, for example, L, WC L, auxiliary, and here, as you can see here, we have 5 here. So we printed the lines here. So if we write it like this, WC C as a parameter, W as a parameter, we will print the words here, and WC C as a parameter, we will print the characters as a C for characters, W for words, and L for lines. So continuing is such a useful general purpose task that the authors of WC designed the command to work with pipes. So it reads from the std in if you omit the file name, and it writes to the std out. So let's use the ls and list contents of the current directory and pipe them to WC to count lines. So the pipeline answers the question, how many lines are visible in my current directory here, and for example ls L here or ls1, and as you can see we have these files and folders in our directory. So if you write like that here, so ls1 and ls1, and we are using pipeline wc1 or L here, we will get 10. So let's count here: 1 2 3 4 5 6 7 8 10 11. 1 2 3 4 5 6 7 10 11. Oops. 1 2 3 4 5 6 7 10 11 12. So we have 12 files here, 12 lines here, as you can see here. Let's delete all of them. So that's because we have the ls, we counted the L with ls1, we counted all of these folders here. It's clear here. So now let's actually write something. So let's WC is the first command you have seen in this lecture, so you're a bit limited in what you can do with pipes. So just for fun, pipe the output of WC itself, so demonstrating that the same command can appear more than once in a pipeline. So this combines command reports that number of words in the output of VC is a 4. So let's make this like that here. So we're gonna use the WC or auxiliary here, auxiliary, and this, oops, why, yeah, why, no, there's no such, or yes, we go on here, ls here, ls, yeah, auxiliary here. So WC auxiliary, and here we have this here. So if we write it like that, WC and or auxiliary and WC W again, and as you can see here, we got 4 here because we are printed here. So let's actually draw that. This is interesting here. So this was our output, right? So our output was 5. Oops, actually it's here. Yeah, our output was 5 6 96 and auxiliary. Yeah, auxiliary. Oops, yeah, auxiliary. So here, let's count it. So this is our first word, 2 3 and 4. So as you can see here, with this command we got the 4 words, and we gave this command to WCW here. That's so as you know, we are getting with WCW, we are getting words here. So we got 4 and not 6 here. So that's an interesting type with the Linux commands here. And let's actually do one more example. Why stop here, right? So let's add a third VC command to the pipeline of the count lines, words, and characters in the output for. So in order to do that, we will here. Oops, why are you doing this? Yeah, clear. So our output was auxiliary here, WC, and as you can see, we got an 4 in previous code command. So WC auxiliary, and here WC W, and we are using again here, so we're gonna use the WC here. So here the output indicates one line containing the number 4, one word containing the number 4 itself, and 2 characters here, and as you can see here, 1 1 2. So here here 4 here, the 4 ends with an invisible new line character here. So 4 ends with an invisible new line characters. That's why we got this output here. So that's enough with the silly pipelines with WCM. As you gain more commands, the pipelines will become more practical. So see you in next lecture. Hello, my name is Tayfun, and in this lecture of our auxiliary course, we will use more examples with ls commands. So, unlike every other Linux command, ls is aware of whether stdout is a screen or whether it's being redirected to a pipe or otherwise. So the reason is friendliness. So when stdout is a screen, ls arranged its output in multiple columns for convenient reading. For example, ls bin here. Oops, here, look, not like this. Yeah, ls bin here. So home and Kali and ls here. So here, and make it clear and ls bin. Yeah, that's enough files here like for us. So this ls bin, so when std is redirected, however, ls produce a single column. So I will demonstrate this by piping the output of the ls to a command that simply reproduces its input, so such as cat. So for example, bin and cat. And as you can see here, we are seeing this just a one line in each here. So oops, we opened so much files right now by just clicking and like this, so we are not using it again. Unfortunately, we did it here. Oops, yeah, whatever. So now the behavior can lead to a strange looking results like this. So let's actually create ls here. Oops, ls. Oops, ls here. And here, let's make it ls wc l here. And as you can see here, we have 10 lines, but as you can see here in the output, we have just one line. So the first ls command prints all file names in one line. So, but the second command reports the ls produced 4 lines. So if you aren't aware of the, no, actually it's 10 lines. So if you aren't aware of the quirky behavior of ls, you might find this dispensary confusing. So ls has options to override its default behavior. So force ls to print a single column with a here -1 option. So we are seeing this now. We can also use force to multiple columns with the C option, so lsc, and as you can see, we use the multiple commands. So if you write, as you can see with this, we've got the ls with wcl, we got 10 as a result because we have 10 lines. And if we do it like that, for example, the, yeah, let's actually write it like that, C and WCL. And as you can see here, we got only 2 lines here. So ls is actually pretty strange if you wanted to understand it deeply here. Hello, my name is Tayfun, and in this lecture of our Oxali course, you will learn about the heat command in Linux. So let's get started. So the heat command prints the first lines of a file. So to print the first 4 lines of our Oxali with here Oxali text file with heat, we can use the option N. So heat N4 and Oxali here. And as you can see here, we printed first 4 lines of our Oxali text file. So if you request more lines than the file contains, the heat prints the full file like cat does. So if you here, let's actually open, and as you can see, we have 6 lines here. So if we write it like that, N11, then it will just print the 6 lines here. So it will print whole file. So he can also read from the std informal pipeline fun. So a command uses to reduce the output from another command when you don't care to see all of it. So like a long directory listing. For example, let's list the first 5 file names in the bin directory here, so ls, or let's actually 15 file names in the bin directory. So bin heat, and it's gonna be 15, and as you can see, we printed first 15 lines in the bin directory. We also have the cut command. So the cut command prints 1 or more columns for a file. For example, let's actually here, so let's print all titles from the Oxali file which appear in the here. For example, cut f2 and Oxali here, and as you can see here, we got this here. So cut provides 2 ways to define what column is. So the first is to cut by field f here. So this f when the input consists of string fields, each separated by a single tab character. So conveniently, this is exactly the format of a file of Oxali here. So the preceding cut command prints the second field of each file. So if you write it like that, 1 here or f3, and as you can see here, so we can also do that like that here, and let's run it again, and as you can see here, we got a different output. So to shorten the output, we can also use the pipe it to heat the print only the first 3 lines, and so on. So now let's actually use the grep command in our Linux command training here. So grep is an extremely powerful command, but for now I will hide most of its capabilities and say it prints lines that match a given string. So for example, let's create like it here, grep Oxali and Oxali here. So Oxali is a text file, so let's actually change it from the UI here, oxali.txt. For if some of you are Windows users, you will understand that this is a text file here. But for Linux, it's actually text files is not stored with a txt file here, so they are just stored a plain file. So here oxali.txt, and as you can see here, we got all the grepped, all the Oxali here. So for example, this command displays lines from Oxali that contain the Oxali string here. So you can also print lines that don't match a given string. So with the v option here, so grep v Oxali, Oxali and oxali.txt, these lines here, as you can see here, we will exclude all of the Oxali commands here. So in general, grep is useful for finding text in a collection of files, and we can also use command print the lines that contain the string Perl in with the names ending here txt. For example, grep auxiliary and txt in a bin here. So we are not in a bin. So in this case, grep here, let's actually go to bin here, cd bin. We can also write it like that to give grep python and txt. Since I don't think we're gonna have here, as you can see here, we don't have any python here. So in this case, if you have a python here, the grep will find matching lines like it did in the auxiliary here and print it on the screen. So we also have the sort command. So actually let's clear this, and the sort command reorders the lines of a file into ascending order by default. So you can also change the descending or other orders here. So for example, sort auxiliary.txt, and that's not sort here, sort. So you cannot read no such file or directory because we are on a bin directory. So we're gonna go to home here, home Kali and ls clear. So sort auxiliary.txt, and as you can see here, it will sort our file. So let's actually edit file, so make it a little more visible like this. For example, write it apple BMW computer Zebra, Windows, Linux, and here. So now we're gonna write it like that, and as you can see, Apple, BMW, computer, Linux, Windows, and lastly Zebra. So it will write it our lines with ascending order. So this is by default. So if you want to change it like this, for example, sort from the descending order, so you're gonna write it like that, R here. So as you can see here, first the Zebra, Windows, Linux, computer, BMW, and that's lastly A here, which is Apple here. So the sort here can order the lines alphabetically by default or numerically with the N option here. So for example, if we write it like that, so actually let's write it here, numbers. Or actually, let's write something like 2002, 2023, 2009, 2010, 2015, 2024, 2025, and 1098 here. So write it like that. And after that, we're gonna use the, for example, cut here, cut. So I will demonstrate this with the pipelines that cut the third field in the animals. So this here, for example, in this case, I'm gonna 6 here, cut F6, auxiliary in the auxiliary txt, and as you can see, we got this here. So let's actually make it like that, cut 1, F1, and as you can see, we got the same output here. So now we're gonna use that cut F3 animals.txt. After we're gonna sort this with this and oops, not animals here, it's gonna be auxiliary here. So auxiliary txt, and as you can see here, we sorted it within the ascending here. So first 98, 2, 9, 10, 15, 23, 24, and 25, but we actually read it quite opposite here. So we ended with 98, and as you can see here, we ended with top numbers, but first we write it with the ascending order here, and as you can see here. So we can also write it descending order by adding after n, we can also add r here, so it will write at descending order, and as you can see, first we've written the highest number, and then it got to from the highest windows here, and as you can see here, this is it. So if you write it like that, sort nr auxiliary.txt, it will write exactly the same output like this. So we also have the unique command. not unique here, so unique here, just unique. So this unique command detects repeated ejacking lines in a file. So by default it removes the repeat. So here, for example, let's add some lines that has same outputs. For example, here, oops, let's open, yeah, let's add some lines. So let's add Linux twice, or here, Windows here, oops, here, here. So now let's demonstrate here, for example, cat auxiliary.txt, and as you can see, we got this here. So we will use the unique auxiliary.txt, and as you can see here, we are not showing the same outputs again and again like this here. So notice that the unique reduced the first three lines to here single in the Linux here. And as you can see here, we got just one Linux, but here we also had two Windows. We got one Windows, and after that we are just seeing one Windows per line, and after that we are seeing another here. So we can also use the, for example, print the gray our lines with cut here. So cut F1 auxiliary txt here. So, and we will also that sort, and here we will use the sort and unique C here, sort NR, and after that heat here in 1, and as you can see, we just got 5 Linux here. The default shell used in many Linux distributions is the GNU. GNU writes like this, GNU here, GNU bash shell. So this is the default shell of our Linux here. This section describes the basic features available in the bash shell, such as the bash manual, tab auto completion, and how to display file contents. You will walk through how to work with the Linux files and directories using the basic commands provided by the new bash shell. If you are already comfortable with the basics in the Linux environment, feel free to skip this section and continue with the next section to see more advanced commands. Let's start with the shell here. The GNU bash shell is a program that provides interactive access to the Linux system. It runs a regular program and is normally started whenever a user logs into terminal. So the shell that's the system's parts depends on your user ID configuration. Here, actually, let's delete it. So it depends on your user ID configuration. So the etc passwd file here, cat etc passwd here. This contains a list of all system users' accounts, along with some basic configuration information about each user. So here's a sample entry from our etc passwd file. And as you can see, this is our user account that has the file name called call. So each entry here has 7 data fields, with the fields separated by colons here. 1, so this is 1, 2, 3, 4, 5, 6, and 7. So this each field separated by colons here, as you can see here. So the system uses the data in these fields against the specific features to the user, for the user. So most of these entries are discussed in more detail in next sections, but for now, just pay attention to the last field, which specifies here. Actually, let's make it like this so you can see it more detail here. Here. So here, just pay attention to this last field here. So which specifies user's shell program. So through this focus on the new bash shell, additional shells are reviewed in this course, and in next lecture we will cover working with alternative shells such as dash and tcsh here. So you will learn in next lecture also different types of shell applications and shells here. So in earlier here, this is their sample entry. The user Typhoon here has been bash set as her default program here, that default program. So here, this means when Typhoon logs into the Linux system, the bash system, the bash shell program is automatically started. So although the bash shell program is started at login, whether a shell command line interface, CLI command line interface is present depending on which login method is used. So if a virtual console terminal is used to log in, the command line interface CLI prompt is automatically presented. So, and you can begin to type shell commands. However, if you log into the Linux system via graphical desktop environment, you need to start a graphical terminal emulator to access the shell command line interface prompt. And we also can use the shell prompt here. So after you start a terminal emulation package or log into the Linux Virtual Console, you can get access to the shell CLI prompt. The prompt is your gateway to the shell. So this is the place where you enter shell commands. So the default prompt symbol for the bash shell is the $sign here, and this symbols actually change like this. And as you can see here, this is the $sign. So this symbol here, let's actually here, this symbol indicates that the shell is waiting for you to enter text. The different Linux distributions use different formats for the prompt. In Ubuntu Linux system, the shell prompt should be look like this and here. And in CentOS, however, this is in the Ubuntu here, Ubuntu. And however, in the CentOS, the default shell writing style will be like this. And $sign. This is in the CentOS OS here. So, besides acting as your access point to the shell, the prompt can provide additional helpful information. Here, in this example, the current user ID named Typhoon here is shown in the prompt. Also, the name of the system is shown here. As you can see, in this case, it's Oxal. This is our host name. So you will learn later in this section about additional items shown in the prompt here. So if you are new to command line interface, keep in mind that after you type in a shell command at prompt, you need to press the enter key to for the shell to act upon your command. For example, if I write like ls here and I need to press enter to execute my command line interface command. So think of the shell command line interface as a helpmate assisting you with your Linux system, giving you helpful insights and letting you know when the shell is ready for new commands. As another helpful item in the shell is the bash manual. In next lecture, you will learn about the bash manual in Linux. So I'm waiting you in next lecture. Most Linux distributions include an online manual for looking up information on shell commands, as well as a lot of new utilities included in the distribution. You should become familiar with the manual because it's invaluable for working with commands, especially when you are trying to figure out various command line parameters. In this lecture of our Oxal course, we will learn about how to interact with the bash manual. My name is Typhoon, and let's get started. The man command provides access to the manual page stored on the Linux system. Entering the man command followed by a specific command name provides the utility's manual entry. For example, in this case, we're gonna write a man ls here, which is we're gonna see almost all the ls commands and ls manual, which is the most important, one of the most important commands in Linux ecosystem here. So notice this command here. We have also the description paragraphs, the synopsis, and the name. ls here, as Linux said, this is the list directory contents. We have description here, which is the list information about the files and or the current directory by default, and we also can sort entries alphabetically if none of the cf or 2sx or sort is specified. So mandatory arguments is a long options are mandatory for short options too, as written here. So when you use the man command to view a command's manual page, they are displayed with something called pager. So a pager is a utility that allows you to page through display text. As you can page here, for example, page here with the various text here and scroll down. So you can also use the arrow keys to scroll forward and backward through the man page text, assuming that your terminal emulation package supports arrow key functions. So when you're finished with the man page, press Q to exit, as here. Press H for help or Q for quit here. So we're gonna press the Q here and here, and the man is gone. And when you're finished with man page, and as you can see here, the man page is gone whenever we've written the Q here. Oops, what happened here? So the manual page here divides information about the command into separate sections, and each section has a conventional naming standards. Here we're gonna make another man here, man cat here. So here we have the name. This name here displays command name and a short description. In this case, cat is concatenate files and print on the standard output. And we also have synopsis here. Actually, let's delete this synopsis here. The synopsis shows command syntax. So firstly we enter the cat, then option, and then lastly file. And we also have the configuration. This configuration provides configuration information here. So we also have the description here. The description describes commands generally. So as you can see here, the concatenate files to standard output with no file, or when file is read, standard output. And we also at the bottom here, we should go to bottom, and we have the copyright examples, author reporting bugs, the copyright, and see also page here in cat command. So the copyright defines the command, obviously copyright defines the command code copyright status. In this case, the copyright is Free Software Foundation GPL v3 plus, version 3 plus, and there is an overrun to the extent permitted by live. This is a free software. And we also have the author here. The author obviously provides information on commands developers written by the Torborn Grandul and Richard M. Stallman. And we also have the C also. So this is a tag. So this C also refers similar available commands. In this case, the similar available command is tag here. So not every command man page has all the section described here. Also some commands have sections names that are not we discussed in next lecture, but in next lecture we will also learn about the several command steps in this man command here. And here, what if you can't remember the command name? So you can search here. Let's actually quit and search. So let's actually, we have a case that you don't you are not remembering the command name. So you can search the main page using keywords. So the syntax is here man here, key here, and then you're gonna enter the keyword. In this case, our keyword, for example, 80. And here, as you can see here, we're gonna find the commands that has 80 in it. And if we scroll down like this, and here we should be able to find the CAT that we here. And as you can see here, this is CAT. This comment here, man find comment, finds us that that contains 80 in it. And in this case, we found our cat comment here. When you log into the system and reach the shell command prompt, you are usually placed in your home directory like this. Often you want to explore other areas in the Linux system besides just your home directory, of course. So this lecture, you will learn how to do that using the shell commands. To start, you need to take a tour of just the Linux file system looks like, so you know where are you going. My name is Stefan, and let's get started. So if you are new to Linux system, you may be confused by how it references files and directories, especially if you are used to the way that the Microsoft Windows operating system does that. So before exploring the Linux system, it helps to have an understanding of what's laid out. So the first difference you will notice in the Linux does not use the drive letters in the path names. So in Windows world, the partitions on physical drives installed on the computer determine the path name of the file. So Windows assigns a letter to each physical disk drive partition, and each one contains its own directory structure for accessing files stored on it. So for example, Windows, maybe you use the sync files like C drive, D drive in Windows, and the Windows file path tells you exactly which physical disk partition contains the file named, for example, test dot the txt here, txt here. So for example, if you save the text.txt on the flash drive, for example, in this case it's the flash drive D here, designated by the letter D, the file path would be like D here and test.txt here. Let's actually make it like that. Test.txt. So this is not the method in the used by Linux, obviously. So this is just a Windows method that I wanted to show you here. So the virtual directory contains the file path. So firstly, the Linux here, this is the Linux file system. The Linux file system stores files with a single directory structure here. So this structure called virtual directory. The virtual directory contains file paths from all the storage devices installed on the computer, merged into a single directory structure. So here you will notice that the Linux uses the forward slashes like this instead of a backward slash like Windows to denote the directories in file paths. So the backward slash character in Linux denotes an escape character and causes all sorts of problems when you use it in a file path. So this might take some time to getting used to it if you are coming from the Windows environment. So in Linux, you will see the path names, for example, the root, home, and in home, for example, we can have the documents here, documents. And in docs we may have the, for example, test.txt. So this here, it's not like Windows, right? So firstly you come from the root, home, then docs directory, and then finally a file here. So this indicates that the file test.txt in the directory is documents under the directory home, which is contained in the directory home. So obviously in the home here you would have the some user here, and then the directories here. So the tricky part about the Linux virtual directory is how it incorporates each storage device. So the first hard drive installed in a Linux system is called the root drive here. So on the root drive, Linux can use special directories as a mount points. So mount points are directories in the virtual directory where you can assign additional storage devices. So Linux causes files and directories to appear within these mount point directories here. Even though they are physically stored on a different drive. So often systems files are physically stored on the root drive here. So usually typically stored on the separate drives or users in Linux. Hello, my name is Stefan, and in this lecture of our Oxford course, you will learn about the Linux directory names. So let's get started. So here, this is our root directory. This is the root of the virtual directory where normally no files are placed here. And this bin here is our binary directory where the many new users or user level utilities are stored. So there are user level utilities. And we also have the boot directory here. That's here. So this is the boot directory. Boot directory where the boot files are stored. Boot files are stored here. We also have the dev directory here. The dev directory, this is the device directory where Linux creates device nodes, which you will learn all of these examples and nodes in next lectures. So we also have the lib directory here. This is our lib directory. This is the library directory where the system and application library files are stored. We also have the libname directory here, but in this representation we don't have that. Actually, yeah. This is the libname directory. This is the library directories where the alternative format systems and application library files are stored. We also have the media here. This media. The media, this is the media directory, a common place for mount points, and this is used for removable media here. For example, USB, external SSD, hard drives, and etc. We also have the MNT here. This is the mount directory. This is a common place used for temporarily mounting file systems. We also have the OPT. This is our OPT here actually. This is our root, and this is OPT. The OPT is an optional directory where the third-party software packages are stored. We also have the proc directory here. PROC here, which in this case we don't have that. But if we take a look at the terminal here, cd here, cd.ls here, ls clear, ls here, and as you can see here we also have that file system here, and as you can see here we have the proc here, this proc. This proc directory, this is the process directory where the current kernel system and process information is stored. We also have the root directory somewhere here. This is the root directory. This root directory, this is the root user's home directory, which is optional. So if you don't have a root system or root user in your Kali system, you don't have the directory, but in most operations and virtual machines, this directory comes default here. We also have the sbin. This is the system binary directory where the many new admin level utilities are stored here. And we also have the SRV here. This SRV is a service directory where the local service store their files here. This is the service where the services store their files service here. And we also have the SIS here. This is the system directory, obviously, where the device drivers and some kernel feature information is stored here. And we also have the TMP. This is the temporary directory where the temporary work files can be stored. And lastly, we have user here. This user, this is a user directory. This is a secondary directory hierarchy. And we also have the var directory here. This is the variable directory for files that change frequently, such as log files. So on the CentOS Linux system, the root virtual directory typically has top level directories within it. So in CentOS, we mostly will have all of these directories, but we are in the Debian in Kali Linux. So in next lecture, you will also learn more details about user directories and how to traverse the directories in Linux. So I'm waiting on next lecture. So you can run commands at a prompt, but what is that prompt? Where does that come from? How are your commands gonna run? And why does it matter? You will get an answer for these questions in this lecture. My name is Tayfun. Welcome to another lecture of our Auxiliary course. Let's get started. That little prompt is produced by a program called shell. Let's actually get our diagram here so we can write things better on screen. So here, so the little prompt is produced by a program called shell. So it's a user interface that sits between you and the Linux interface here. So here, for example, in the left side this is you here, and here this is our famous penguin. So I can't draw penguin right now, but I will try here. So this is our penguin here, and here this is our penguin. Yeah. Here, so this is the shell that sits between you and the Linux operating system. So Linux supplies several shells, and the most common and the standard for this course is called the bash shell. So actually, let's actually write this. So we're gonna use that as we're gonna use that as a bash shell. Bash. So this is just a standard that most widely used shell type in Linux here. So bash and other shells do much more than simply run commands. For example, actually, let's delete this. Yeah. For example, when a command includes a wildcard here, so this is a wildcard. This is a wildcard operator. This refers to multiple files at once. So for example, ls here. Let's actually go to bin. So we have more files on bin here. So for example, ls. Let's find the C here, and as you can see, we get C file. Oops, not like this. ls like this, and as you can see, no such file or directory. For example, we access the multiple files at once, but in this case we don't have a C file here. So let's actually, instead of writing finding folders, let's go to Python here. So I think we're gonna have Python 3 point Python 3 point. Yeah, that's actually find this here. Let's actually here. OpenSSL. So let's go here. OpenSSL, ls. So let's look what we here see the OpenSSL with the directory. Yeah, OpenSSL apparently is a file. Yeah, that's it. So for example, ls something like that, you're gonna see all of this here. So the wildcard here, we will use the wildcard in the next lectures too. So the wildcard is handled entirely by the shell, not by the program ls here. So the shell evaluates the expression here. For example, let's actually write this like clear cd home and Kali, Kali here. So here, for example, ls, yeah, the R code here, the wildcard operator, for example, ls the dot pi or ls txt, we had txt files, right? And as you can see, we got on here. So if we copy this txt files right now, and here let's open our text here right now, oxel txt, copy here like this. So now, yeah, here, and as you can see, we got all the copies here. So here the wildcard, and as you can see here, the shell evaluates the expression, the wildcard operator .txt, and invisibly replaces it with a list of matching file names before ls runs. So in other words, ls never sees the wildcard here. So for the perspective of ls, the type following command is going to be, for example, ls the auxiliary. Oops, actually, let's first, yeah, auxiliary here, ls auxiliary copy, for example, copy 1 and copy 1, yes, or no, we don't have, yeah, copy 10, for example, and after that txt, and then it comes auxiliary.txt, or like auxiliary, again, auxiliary copy txt, copy, for example, yeah, 8 or 6 here, auxiliary copy like this, and here, as you can see, we got an error. So our this wildcard operator sees like this. So the shell also handles pipes, as you saw in the first section of this course. So it redirects the std in and std out transparently, so that the programs involved have no idea they are communicating with each other. So every time a command runs, some steps are the responsibility of the invoked program, such as ls. So at some there are the responsibility here are the responsible of the shell. So expert users understand which is which. So that's one reason they create a long complex command off the top of their head and run them successfully. So they already know what the command will do before they press enter. So in part because they understand the separation between shell and programs it invoked. So in this lecture, we will launch you understanding of the Linux shell. I will take the same minimalist approach I used for commands and pipes in previous lectures, rather than cover dozens of shell features, and I will hand you just enough information to carry you to the next step of our learning journey. So in this lecture, you will learn about the pattern matching for file names. You will learn redirection of input and outputs. You will learn variables to store valuables, quoting and escaping to disable certain shell features, the search path for locating programs to run, and lastly, you will learn how to save changes to your shell environment. So I'm waiting you in the next lecture. See you later. Hello, my name is Tayfun and welcome to another lecture of our Auxiliary course. In this lecture of our Auxiliary course, you will learn about the traversing directories and you will use the absolute directories for references. So let's get started. So you change the directory to move your shell session to another directory in the Linux file system. So the cd command, this syntax is pretty simple. So you first enter the cd, which means change directory, and after that you enter the destination here. So the cd command may take a single argument as a destination here. So you will enter destination here. So which this destination specifies a directory you want to go. So if you don't specify a destination on the cd command, it takes you to your home directory here. So if you make it like that, cd downloads, and after that cd, and as you can see here, we go to home directory again. So you will, in this chapter, you will learn the each of these methods, and you will learn about the differences between these two methods are important to understand as you traverse the file system. So you can reference a directory name within the virtual directory system using the absolute directory reference. So the absolute directory reference defines exactly where the directory is in the virtual directory structure and starting at the root. So think of the absolute directory reference as the full name for the directory. So an absolute directory reference always begins with a forward slash indicating the virtual directory system's root. So to reference user binaries contained within the USR directories some directory here. So you will use user here, and here you can also, as you can see, whenever I click to the tab here, so whenever I click to the tab button on my keyboard, it will show make possible inputs for my command here. So in this case we will enter the bin here, so user bin, and as you can see we changed our directory to user bin. So there's a node up to as to exactly where you want to go. So to move to a specific location in the file system using the absolute directory reference, you just specify the path name in the cd command. So we can also do it like that. For example, let's make it go to home, and as you can see we are in the home, and let's go to user bin, user bin, and as you can see here we changed our directory to user bin here. Also, did you notice that this example, that the prompt originally had a title here, had a title in it, and after the change to nav directory occurred, the title was replaced by bin here. As you can see here, firstly we had a title here, but whenever we clicked and changed the directory, there we showed us that we are at a different directory other than our home directory here. So this is where this command line interface prompt can help you keep track of where you are in the virtual directory structure. So the tilde indicates that your cell session is located in your home directory like this. For example, let's go to home, and as you can see we are in the home now. So after you move out of your home directory, the partial directory reference is shown in the prompt. So if the prompt has been configured to do so. So if your prompt has not been configured to show the shell session current absolute directory location, then you can display the location via a shell command. The pwd command displays the shell session's current directory location, which is called the present. Actually, let me write it right here. So this called present working directory. Here, as you can see, pwd means that present working directory. So if we write the pwd here, and as you can see we printed as the our working directory in our shell here. So if we go to user bin, cd user bin, or again cd bin here, and whenever we write the pwd, present working directory, and as you can see here, we printed our current working directory. As you can see, these are not the same because we changed our working directory. So you can move to any level within the entire Linux virtual directory structure from any level using the absolute directory reference. We can also go to, for example, cd, actually let's clear. We can also go to cd var log here, and as you can see here, we got to var log. So this changed here, and whenever we write the pwd, and as you can see here, we are seeing our working directory now. So you can also quickly jump to your home directory from any level within the Linux virtual directory structure with just a simple cd command, and as you can see here, we are in the home now. However, if you are just working with your own home directory structure, often using absolute directory references can get tedious. So for example, if you are already in the directory of our home column, it seems somewhat cumbersome to have to type this command. So cd home Kali, and after that documents here, or Kali to downloads here. And as you can see, we got to downloads. So you can just get to your documents directory. Fortunately, there is a simpler solution. We can use the, instead of using, so actually let me write that down here. So in this here, this whole lecture, we use the absolute, or actually we can, so we use the absolute path directory, APD. But now we're gonna use the relative directory here. So now in order to do that, this is just a simple here. So instead of writing cd home Kali Linux download, now we can just write here, actually let's go to our, here's clear cd. So we are in the home directory pwd. As you can see, we are in the home directory now. In order to go to downloads again, just write the downloads, cd downloads, and as you can see here, we got into the downloads here. So relative directory references allows you the specific destination directory reference relative to your current location. So a relative directory reference doesn't start with the / as you can see here. Instead, a relative directory reference starts with either a directory name, so if you are traversing to a directory under your current directory, or a special character. For example, if you are in your home directory and want to move to your here downloads directory or downloads subdirectory, you can use the cd command along with a relative directory reference. So here, let's actually go to different here. So cd pictures. Oops, do we have pictures here? Yeah, ls, and as you can see, yeah, cd pictures, and as you can see, we changed our directory to pictures, and yeah, pwd, and as you can see, we are in the pictures directory. So in this example, I want to note that the no forward slashes was used. So instead, the relative directory reference was used, and preset the work directory was changed from our home Kali to home Kali pictures with, or downloads with less with less typing. I'm waiting you in the next lecture. As you have seen in previous examples, by default, the ls command lists all the hidden directory files. So sometimes this can be overkill, especially when you're just looking for information on a few files. So fortunately, the ls command also provides a way for you to define a filter on the command line. So it uses the filter to determine which files or directories it should display in the output. So before using the filter command here, let's create some files to play with the via torch command here, so which you will learn torch command in more detail in next lecture. So let's actually, by creating torch here, so let's create our file names. So my file auxiliary academy, my document, just a picture, and yeah, that's, I think that's okay enough. Yeah, and here the ls, and as you can see here, just a picture, my document, my file, and auxiliary academy is created here. So now let's actually create another image, another file too. So touch, and in order to do that, so let's actually create the file, fill, and full. Here we also created this, and file, fill, and full. So the filter command works as simple text matching strings. So include the filter after any command line parameters you want to use, like this for L here, for example. In this case, we're gonna use the L long here. So now we're gonna create, for example, my file. Yeah, right, my file. And as you can see here, we specified the name of the specific file as the filter. So the ls command only shows this file information. Sometimes you might not know the exact file name you're looking for, and the ls command also recognizes standard wildcat characters and uses them to match patterns with the filter. So a question mark here represents one character. So ls, a question mark, represents one character here. So you can do like this. Let's actually create. So here, let's actually open our marker. Oops, sorry. Yeah, let's open our marker G here. Yeah, grommet. And now I want to write something on here. So firstly, as we created our files, we have file. Firstly, file. So then we have fill, and then we have fill, and also lastly we have full here. So let's actually, what these characters and sentences has common is that they always start with F, and the last characters is always L here. So in this case, if we want to filter this, we can also do this. For example, yes, here. So let's create new file. In order to do that, we're gonna do, yeah, lsl here. Oops, lsl, and as you can see here, we have file, full, fill, and other documents here. So if we want to just print these files, we need to do ls here, clear lsl. So we're gonna do here lsl f question mark and fill, or ll here. And as you can see here, we are this question mark, as I said earlier, is represents one character. So this question mark represents one character that we don't know, but we want to search these terms here, as you can see here. So here we added the question mark here. So we added here f question mark and ll. So this tells us that start four characters that start with the f, and end to the last two characters has two l's on it. So we just want to filter this here. So we also have the asterisk to represent any number of characters, but here, for example, we can also do, let's actually delete this. Yeah, we can also, so here we had the my file, my document, just a picture, and let's create another here, touch and my auxiliary, touch my Linux, and ls here, clear, firstly lsl, and as you can see here, my document, my file, my Linux, my auxiliary. So in order to do that, we're gonna do here ls, oops, yeah, lsl here. So we're gonna do, so as you know here, so we have the my document, also we have here my file, Also we have my Linux. Also lastly my Oxley. Here. So now in order to search these files, as you can see here with the lsl command, we got like wide range of files. But if we want to filter these files and filter names that start with the my here, mi or other characters, we're gonna do just this here. So let's get here and we will do my and this asterisk, and here it will show us files that start with my. So we can also do that with this here. So lsl f and asterisk instead of here, and as you can see here we got the same result. But actually these are not the same, of course. If we, for example, let's create another file, touch fail, and here we will enter our old command. So clear lsl, and as you can see we have fail, fall, fill, and full. And here we're gonna do, we will do the previous command here, f, and here ll here, and as you can see we don't see our fail here because fail last two characters is not ll here. So that's it with our example here. In next lecture I will talk about the handling and creating files in Linux. So see you later. Hello, welcome to another lecture of our auxiliary course. In this lecture you will learn about how to handle, create, modify and delete files. So the shell provides many file manipulation commands on the Linux file system. This lecture we will walk through the basic commands and the basic shell commands you need to handle files. So let's get started. My name is Stefan. Welcome to another lecture of our auxiliary course. Every once in a while, you run into a situation where you need to create an empty file. For example, sometimes applications accept a log file to be present before they can write to it. In these situations, you can use the touch command to easily create an empty file. In order to do that, for example, touch and my test file here, and as you can see here, we created touch my test file. So the touch command creates the new file you specify and assigns your username as the file owner like this. So as you can see here, my username is the file owner and my machine is Kali here. So notice in this example that the file size is 0 because the touch command just created an empty file. So that touch command can also be used to change modification time. So this is done without changing the file contents. So we will do, for example, and as you can see here, 313, and as you can see, this is 313 now. So let's create again, and my test file 2, and here lsl clear lsl. And as you can see here, these have different times. They also created a time for them. So yeah, and actually if you want to update this file like this, so we can also write test file, write the same name, and as you can see here, we updated file time here. So creating empty files and altering file timestamps is not something you will do on a Linux system daily. However, copying files is an action you will do often while using shell. So let's get started with copying files here. So copying files and directories from one location in the file system to another is a common practice for system administrators. So the cp command provides this feature. In its most basic form, the cp command uses two parameters. So two parameters. The first parameter is that cp is the source object. So in this case, we're gonna firstly assign source, and after that we will enter the destination. So here, when both source and destinations are parameters or file names, the cp command copies the source file to a new destination file. So the new file acts like a brand new file and with an updated modification time. So for example, let's do following here, lsl, and here we have my test file too. So let's copy my test file to the same location, but change the name to test here, test file. Yeah, test file, and let's do it. So we're gonna do, in order to do that, we're gonna do my test file. Firstly, we're gonna enter the source here, so my test file, and after that we're gonna enter the destination, and as you can see, the destination is gonna be this. So destination is gonna be test file, and here, oops, clear and lsl, and here, as you can see here, we have a test file, with the new timestamp 315. But here, as you can see here, whenever we copied this also created a new timestamp, but as you can see here, but the size and their contents should be the same. So the new test file shows a different modification time than our previous the test file. So if a destination file already exists, the cp command may not prompt you to this fact. So it is best to add the e option here. So e option to force the shell to ask whether you want to override a file or not. So we will do that like this, ls or cp here, parameter as e here, and override test file, yes, or e here, and as you can see here, l here. You can also here, let's see, and as you can see here, we override on the test file, and the timestamp and file contents should be updated with new file here. So if you don't answer the u here, so u here, the file copy doesn't proceed, and you can also enter the n here, so for no. So you can also copy a file into pre-existing directory like this. We're choosing the absolute directory, so cp or clear firstly. So cp e, for example, my test file, and we're gonna do to my home Kali, and after that we will copy to, for example, templates or downloads. And here let's see the two downloads. Oops, see the two downloads here. As you can see here, we have a new file, my test file here. So the new file is now under the downloads directory using the same file name as the original. Hello, in this lecture you will learn about the tab autocomplete in Linux. So let's get started. So when working at the command line, you can easily mistype a command, directory name, or a file name. In fact, the longer directory reference or a file name, the greater chance you have on mistyping it. This is where our autocomplete can be a lifesaver. So the autocomplete allows you to start typing a file name or a directory name and then press a tab key to have the shell complete it for you. So for example, in this case we have ls, and as you can see we have my test file 2, and my very 19 lengthy file here. And so when you write like this, ls my here, and you will show directories that start with my and underscore. So when you want to copy here, for example, so copy my or my here, and as you can see we have several options. Whenever I click on the tab, I'm going through these files here. So after selecting with the tab here and press enter your chosen file. And here after that we will, for example, enter in new file, and here we copied our my very lengthy file to new file here. So lsl here, and as you can see here, the new file is just created in that time here. As you can see here, 134. So in this example, we typed the cp and then press the tab key, or we actually typed the my cp here, cp my, and we press the tab key, and then shell autocomplete the rest of the file name. Of course, the destination directory had to be typed, but still autocomplete saved the command from several potential typographical errors. So the trick to using the autocomplete is to give the shell enough file name characters so it can distinguish the desired file from the other files. For example, if another file name started with, for example, really, or let's actually try what we have. Yeah, if another file name started with test here, pressing the keyword here, or like this, ls test, and pressing the keyword here that starts with TE here will show us our potential files that we are searching for. So instead you will hear a beep if you don't have anything to show you. So if this happens, you can press the tab key again, and the shell shows you all the file names started with really. So this feature allows you to see what needs to be typed for tab autocomplete to work properly. Linking files. Linking files is a great option in the Linux file system. If you need to maintain 2 or more copies of the same file on the system, instead of having a separate physical copies, you can use one physical copy and multiple virtual copies called links. Actually, yeah, links here like this. Let me actually open our Gromit and write it right down here. Yeah, here, links. Oops. So, a link is a placeholder in a directory that points to real location of file. So there's a two type of links here. So let's actually make it circle, and the first type is a symbolic link. Here, symbolic. And the second type is hard link. So a symbolic link is simply a physical file that points to another file somewhere in the virtual directory structure. So that's two symbolically linked together files do not share the same contents. So to create a symbolic link to a file, the original file must pre-exist. So you can then use the ln command with the s option to create a symbolic link here. So ls here, for example, let's write our file, and here open our file manager, open folder, and for example, let's create a test file, write something in it here, and so we have some 531 bytes in it that we will write it here. So we will do lsl here, test file, and here, as you can see here, we have bytes and the test file here, and as you can see, we have seen our permissions here. So in order to do that, we will use ln s, and for example, we will do it the test file firstly. We will pass our file, real file, and then we will sl here, test file. Or you can, yeah, you can also use that like that. Yeah, they don't have to share the same name or same name structure. So in this example here, let's actually lsl, and here in this example, notice that the name of the symbolic link SL data file test file is listed second in the ln command, as you can see here. So the symbol here, actually let me, and as you can see, this is the symbol here. This symbol here displayed after the symbolic link files long listing shows that it is symbolically linked to the file test file, as you can see here. So also I want to note that the symbolic link file size versus the data file size. So the symbolic link SL file size here is only 9 bytes, where our data file has 531 bytes in it. So this is because our SL test file is only pointing to our test file, so it actually doesn't contain any contents in it. So they do not share contents, and they are physically two separate files in our directory file system, but our SL file is only purpose to show that where our test file is. So another way to tell these linked files are separate physical files is by viewing their inode number. So the inode number of a file directory is a unique identification number that the kernel assigns to each object in the file system. So to view a file or a directory's inode number, you can simply use the e parameter here. Actually, it's clear. And you can simply use e parameter right here, and then after that we will pass our test file. And as you can see, this is our inode number for our test file, and that's actually in here, and oops, not like this. That's clear. Test file, and then we will do, oops, not like this. Yeah, SL test file, we're gonna write it right here. So test file, and here we will do SL test file. And as you can see here, there are two different inode numbers. So remember that inode numbers are only assigned once in every file here, so cannot be two inode files for now, but you will learn about inode numbers in next lectures. So another way to tell here that we can also, this example showed us that the file inode number, our data file inode number is 3932329, while our SL test file is 3932659, as you can see here. So a hard link creates a separate virtual file. So actually they are the different files, right? We got it. Yeah, they are the different files to hold different files. But the hard link creates a separate virtual file that contains information about the original file and where to locate it. However, they are physically the same file. So when you reference the hard link file, it is just as if you are referencing the original file. So to create a hard link, again, the original file must pre-exist. In this case, our original file is my test file. Except that this time, there's no parameter is needed on the ln command. In order to do that, we're gonna create ln. So actually, we learned about the symbolic line here. So we learned about symbolic. Now we're gonna learn about the hard link lines. So now we're gonna write ln my test file, and after that we're gonna use the hard link. So in this case, SL that we mentioned, that SL is a symbolic, and in this case let's actually write hard link to notify us that this is the hard link file, or another users that notify us that this is a hard link file and not symbolic file, symbolic link. So in this case, let's actually test file. And here we created our hard link file, clear lsla, oops, lsl, yeah, here. and let's find where, yeah, as you can see here, this is test file, hard link file. So in this example, actually we need also create, let's actually create the first this, yeah, let's actually ls, and I will explain all of this here, le here, and we will make it what was our hard link file here in this case is rhl test file, and ls le here code oops, no, not code here, test file, and here as you can see 0 bytes. And now let's actually use our my test file. Yeah, actually I forgot what we are working with. Yeah, it has to be test file. Yeah, test file. In previously, oops, we actually created wrong file name. We need to create a test file here, so we will delete it. And as you can see, I want to show how hard link files look like. And as you can see, SL has a tick like this in the UI graphical interface, but HL doesn't have any ticks. And here, as you can see here, it's empty because we created from the empty file. Actually, my test file is empty, as you can see here. So let's also delete this here. Yeah, now we're gonna use the test file, which is we've written some contents in it here, and now we're gonna use the ls le here. No, firstly we're gonna create the ln or my test file or test file, and after that hl my or test file, right? Just a test file, create a hard link. This because the test file of hard link exists. Actually, let's test file my text file here, my test file, and we created our hard link. And now we're gonna also show our hard link file here. So la here. So in this case, we're gonna use the test file, and here, as you can see, we got another example. So in this example, we use the lsle command to show both the inode numbers and the long listing numbers for the code files. Actually, let's also show, I want to show you how our inode number looks of our hard link file, in this case hl my test file. And here, as you can see here, these inode numbers are the same. So these both files, which are hard linked together, share the same inode number. This is because they are physically the same file, and as you can see, these all of them are the same size. This is because they are physically the same file. And here we have two links. In addition, their file size is exactly the same as well. So be careful when copying the linked files. If you are use the cp command. Actually, let's take it. Yeah, if you use the cp command to copy a file that's linked to another source file, all you are doing is making another copy of the source file. So this can quickly get confusing. Instead of copying the linked file, you can create another link to the original file, and you can have many links to the same file with no problems. However, you also don't want to create a soft links to the other soft linked files. So this creates a chain of links that can be confusing and easily broken, causing all sorts of problems. So you may find symbolic and hard link difficult concepts. Fortunately, renaming files in the next lecture is a great deal easier to understand that. So I'm waiting you in next lecture. The mkdir command is used to create directories, and here let's actually write our mkdir, how it looks like here. So mkdir, let's actually make directory here, basically make dir. So here, in order to work with mkdir here, you're gonna firstly use the mkdir, and after that you will enter the directory name. So here that when 3 periods full of an argument in the description of a command, here for example my dir 1, so it means that the argument can be repeated. So use here with this, we created just a single command in order to do more than one directory. So you can also do this. Mkdir here, mkdir, my dir 2, my dir 3, or my dir 3, my dir 4, my special, and here, as you can see here, we created my dir 1, 2, 3, 4, and my special dir here. So we can also use the cp copy files and directories command here. Actually, let me write it right down here. Yeah, cp. Basically, it's copies here. We can with this command we can copy files and directories. As I said, the cp command copies files and directories, and it can be used in two different ways. So we can also actually let's see what files we have. So this is our directory we will work in. Oops, this is our directory we're gonna work in, and this is our file we're gonna use the cp command here. So first you will cp, for example, file my copied file here, and ls, and as you can see we created my copied file. So we copied this file to this here. So we can also copy the single file or directory item 1 to the file or directory item 2. So we can also do that, for example, cp file, and after that we can also music here, and ls cd music, and ls here, and as you can see here we copied our file inside our music directory here. That's it, with basic introduction of cp command here. So you can also learn more information with man cp, and here as you can see here cp is for used copy files and directories, copy source or to destination or multiple source to a directory, and mandatory arguments to long options are mandatory for short options too. And as you can see we have archive attributes only, backup, the reference, preserve links, and another commands here. So you can also learn more about the cp command. It's actually the most popular command, one of the most popular commands in Linux. So let's create an examples with it right now. And firstly, let's actually use the mv command. mv command, as the name suggests, mv moves and is used for moving and renaming files in Linux. So the mv command performs both file and file renaming. So file moving and file renaming depending on how it is used. In either case, the original file name no longer exists after the operation. So mv used in much the same way as a cp. For example, mv, firstly we're gonna ls, mv file here, and after that my renamed file, and ls, and as you can see here we renamed our file, and the file no longer exists. Here with the mv commands, with e here, mve, this is the interactive means here. So before overwriting an existing file, prompt the user for confirmation. If the option is not specified, mv will silently overwrite files. So for example, let's try with this mv renamed file, and to old file, and ls, and as you can see this is specified without asking to do it or not. So let's actually learn about rm command here. rm here. Oops, actually let's make it a bit nicer. rm here. This is, as the name suggests, remove here. So the rm command is used to remove, delete files and directories with just a single command. In order to do that, we're gonna actually go to here, clear rm here, and after that we will actually let ls, and as you can see we have file named old file, rm old file, and here as you can see we no longer have files here. So you can also use the same options and in the previous mv command. For example, you can also use the interactive, so touch some files, and here, as you can see, we created a new file. You can also rm here and test, and as you can see here, now it asks for do we want to remove the file tsmd, and you can yes, and as you can see here, our file is removed. We can also, in the previous lecture, we did learn creating links and hard link symbolic links, which you will learn in more depth in next lecture. So I'm waiting your next lecture. Hello, my name is Tayfun. Welcome to another lecture of our auxiliary course. In this section, we are going to look at some of the magic that occurs on the command line when we press the Enter key. While we will examine several interesting and complex features of the shell, we will do it with just one new command, which is echo to display the line of the text. So let's get started. Each time we type a command and press the Enter key, Bash performs several substitutions upon the text before it carries out our command. So we have seen a couple of cases of how a simple character sequence, for example, this asterisk, can have a lot of meaning on the shell. So the process that makes this happen is called the expansion. Actually, let me mention it here. So expansion. So with expansion, we enter something and it is expanded into something else before the shell acts upon. So to demonstrate that, what we mean by this, let's look at the echo command here. Actually here. So let's look at the echo command. So echo here is a shell built-in that performs a very simple task. It prints its text arguments on a standard output. So if you write it like that, so echo, this is auxiliary lecture, and here, as you can see here, we write it, this is auxiliary lecture. So that's pretty straightforward, right? So any argument passed to echo gets displayed. So let's try another example here. So clear echo this here asterisk, and as you can see, we write this. So for example, echo ls, echo ls, oops, ls, and here we can also write it like that. And as you can see here, each argument we write in echo, we are just seeing it. So here, let's write the path name expansion and learn more about it. So the mechanism by which wildcards work is called the path name expansion. If we try some of the techniques that we employed in earlier lectures, we will see that they are really expansions. So given a home directory that looks like here, for example, ls and oops, actual cd here, ls, and here echo here, and as you can see here, we've rated our like ls here. So clear, and let's echo d here, and here, as you can see here, we started d arguments. So we can also do it like that. For example, echo s here, and as you can see here, we will print that templates or documents that ends with s character. We can also do it like that. Echo to here bases like that, and upper, and here like that, and after the asterisk here, and as you can see here, we printed all of that starts with the uppercase character. And we can also do it like that. For example, echo that's actually that's pretty complex and straightforward commands with which you will learn all of echo commands in this course. So echo, for example, user asterisk wildcard operator, some called asterisk, some called wildcard here, share, and as you can see here, we printed our user local share. So that is called the path name expansion of a hidden files. So as we know, files that begin with the period characters are hidden. So a path-name expansion also respects this behavior, and expansions such as this here, echo this asterisk, this will not reveal hidden files. So it might appear at first glance that we could include hidden files in an expansion, for example, like this, that starts with this, by starting a pattern with a leading period like this, and as you can see here, we got it, but it almost works. However, if we examine the results closely, we will see that the names from that start with dot and double dot here will also appear in the results, because these names refer to the current working directory and its parent directory. Using this pattern will likely produce an incorrect result. So we can see this if we try this command here, clear, and here we will lsd and wildcard operator. After that we will use pipes and the less here, and as you can see here, we got this our desired results here. So actually, let's end this. Oops. Here. Oh, can we change this color? I didn't realize that we can change the color of this. Here. Yeah, let's quit. So whatever, here. Now we're gonna use this echo and echo dot braces and here asterisk, and as you can see here, the event not found, we got an error here. So this pattern here, echo, and as you can see here, this. So this pattern expands into every file name that begins with only one followed by another characters. So this will work correctly with most hidden files, so it won't include file names with multiple leading periods, and the ls command with this a option, uppercase A option, will print us that. And we will, and as you can see, we got a correct listing of a hidden files. So I'm waiting you in next lecture. Arithmetic expansions in shell. The shell allows arithmetics to be performed by an expansion. So this allows us to use the shell prompt as a calculator. So for example, let's do this. Echo, and now we're gonna do here braces, braces here. And for example, 2 plus 2. And as you can see here, we got an 4. So arithmetic expansions you can be used like this. For example, you will firstly, let's actually use our grommet. So you will use the expansion, the $sign, and after that, 2 braces here, and you write your expression here, expression. Here, now use 2 curly braces again, and after that, that's it. So of course, don't forget to write your echo command before then. So here we have just an empty space. So where expression is an arithmetic expression consisting of values and arithmetic operators. So arithmetic expansion supports only integers, whole numbers, no decimals, but can perform quite a number of different operations. So for example, it can be used for addition, for subtraction, for multiplication, for division, but remember, since expansion supports only integer arithmetic, the results is gonna be always integer output. And it also supports modulo, which simply means remainder, and we also have exponentiation, which is 2 here. So we also have an exponentation here. So spaces are not significant in arithmetic operations, and expressions can be nested. For example, here, let's do another example like this. So for example, let's write echo here. So we will write nested expression right here, and after that two braces again, after dollar sign, and now 5 multiplication 2, not this is not a multiplication, actually it's exponentation, and after that we will use that 3. And here let's see the results here. So single parenthesis, this is our results here. So a single parenthesis may be used to group a multiple sub-expressions. With this technique you can rewrite the previous example and get the same result using the single expression instead of 2. And we can also write the strings and mix it together. So echo, for example, 5 divided by 2 equals, and after that we will enter our division here. So 5 divided by 2, and here, and as you can see here, 5 divided by 2 equals 2. Yeah, that's actually not a, yeah, this actually true, but and I said earlier that these expressions in echo supports only integer arithmetic, and the result is gonna be integers. Perhaps the strangest expansion is called the brace expansion. Actually, let me write that down here. So in this lecture, we'll learn about the brace expansion. So with the brace expansion, you can create a multiple text strings from a pattern containing braces. So for example, this here, let me change this to here. So echo, for example, and make it auxiliary and A, B, C, D, and academy. And as you can see here, we can here this is the following output: auxiliary A academy, auxiliary B, auxiliary C academy, auxiliary D academy. So patterns to be brace expanded may contain a leading portion called a preamble and a trailing portion called a postscript. So the brace expansion itself may contain either a comma separated list of strings or a range of integers or a single characters. So the pattern may not contain unquoted white space. So here is an example, for example, echo. So now we will write following example: lecture number, and here, for example, lecture number from 1 to 20 here. Oops, not like this, here. That's it. And as you can see here, lecture number 1, lecture number 2, lecture number 3, 4, 5, 6, 7, 8, and from 1 to 20. I think you are getting the logic of this expansions here. So now we can also do it like that. So clear, and echo 01 from 01 to 99 here, and we will get this following output here. And you can also do it from, for example, 001 to 099, and you would also get this output. So if you tried it something like that, and here you would also get the same output, because it starts with 001 and then ends to 99 here. You can also do something like that. For example, echo, you can use the range of ladders in a reverse order like this. So from Z to A, and here, and as you can see here, we got from Z, AX, and lastly A here. So we reversed the ladders here. So and you can also reverse this numbers here, so you can also write from 99 to 1. So for example, echo 99 to 1, and here you can also do it from 099 to 1, and you can also do 099 to 000, and as you can see here 099, and lastly 000. So let's think of like that. What is this good for? The most common application is to make lists of files or directories to be created. For example, if we were photographers and had a large collection of images that we wanted to organize into years and months, the first thing we might do is create a series of directories named, for example, yes, and actually let me write it down here so you will understand better. So the first thing we're gonna do is create a series of directories named, for example, year, and after month. So this way, the directory names would sort in a chronological order, and we could type out a complete list of directories, but that's a lot of work in this case, and it's error prone. So instead we could do here in next example, but firstly what we want to do here, for example, October, and the month is going to be, for example, no, year first. So first we're going to write a year here. So year is going to be, for example, 2024 October, and inside this we're going to have the photographs. So this is going to be directory here, and this is going to be our directory, and inside this we're going to save and order photographs in it. So let's get started with our example now. And here, firstly we're gonna ls here. So firstly we're gonna go to documents or another directory, so we won't see the other useless directories here. Or let's actually go to cd my dir one and ls, so we don't have any files in it. That's good. And for example, make dir photos, yeah, photos, and here we created the dir photos, so we're gonna cd to photos here, photos, and now we will make the dir here. So now that's here, for example, my mcod dir here, and from 2024 or 2020 to from 2020 to 2025. And here, and we will also write a month number. So in this case, the month numbers is going to be 01, 02, 03, 04, 05, 06, also 07, 08, 09, not 0 here, 10, and 11 and 12. So the month's order is going to be like this here. So let's here, in order to do that, we will write it 01 to 12, and here let's create enter, and here let's see the magic here, ls, and as you can see here, lsl here, and as you can see here, actually we did an mistake here because we did write it like that. So now let's actually see what did create what did we create. And here, as you can see here, we create, actually we didn't mistyped the error. Instead of writing this, we have to write 2 space characters. So clear, let's write it again. So we don't have any files, ls, and here we will do mcdir, and from 2020 to 2025, and here 01, from 01 to 12. And here, as you can see here, we did create our folders for it. So for example, this is 2021, 2022, 2023, 2024, and it goes like this to from 2021 to our 2025 12 here. And this is pretty like magic, right? So in next lecture you will also learn about the parameter expansion. So I'm waiting you in next lecture. We are going to touch only briefly on a parameter expansion in this lecture. Let's clear the console first. So, but we will be covering it extensively later, just to mention that. So it's a feature that is more useful in shell scripts and directly on the command line. So many of its capabilities have to do with the system's ability to store small chunks of data and to give each chunk a name. Many such chunks, more properly called, are variables, are available for your examination. So for example, the variable user contains username. To invoke parameter expansion and reveal the contents of user, you should do this: echo $sign and user. And here, as you can see here, I printed my username. So to see a list of available variables, you can also try this: print any v here and less here. We will use less. And as you can see here, we have this system variables, and which is color fpg. You can, and the home directory is this. Our language log name is Typhoon. Password, oh no, it's actually pwd here. This is the working directory that we are in, and here we have information about that. So let's actually end this here. Oops, here. Exit this, and here with Control Q, or for example, and as you can see, press return log file is already in use. So we are use this log file, and here we are going to exit it now with Control Z. So you may have noticed that with other types of expansion, and as you can see, we have our current working directory is pwd. So we're gonna clear and cd here, and again cd. Let's go home here and ls, and as you can see, we are in the home here. So as I said, if you notice with other types of expansion, if you mistype a pattern, the expansion will not take place, and the echo command will simply display the mistyped pattern. So with parameter expansion, if you misspell the name of variable, the expansion will still take place, but will result in an empty string. So for example, this. So as you remember in previous minutes of our lecture, we print our username with user, but if we write it like that, echo suyer here, or yeah, suyer. So actually it's a misspelled type of the user when and as you can see here, we got nothing as an error, and it's just a new line. So you will also learn about the command substitution in this lecture. So command substitution allows us to the output of a command as an expansion. So in order to do that, we will echo, and here inside the braces we will use ls, and here, and as you can see, we got this command here. So, and one of my favorites is this here, which and cp, and as you can see here, we got this. So here we pass the results of which cp as an argument to the ls command, thereby getting the list of the cp program without to know its full path name. So we are not limited just to simple commands. Entire pipelines can be used for example and working with it. We also have the cool thing here. So now that we have seen how many ways the shell can perform expansions, it's time to learn how we can control it. So take for example this echo. This is auxiliary, and oops, not like this. Oh, this is auxiliary academy, and as you can see here, this ignored all of these spaces here. And you can also do, for example, echo the total price is, for example, $100, and here, and as you can see here, the total price is 0. So in this first example with this, word splitting by the shell removed extra white space from the echo command. And the echo command's list of arguments. So in the second example, parameter expansion substitute an empty string for the value of $100 because it was an undefined variable. So the shell provides a mechanism called quoting to selectively suppress the unwanted expressions here. We also have the double quotes here. So the first type of quoting we will look at is double quotes. If you place text inside the double quotes, all the special characters used by the shell lose their special meaning and are treated as our ordinary characters. So the expressions are $sign and backslash and backtick here. Backtick. So this means that the word splitting, path-name expansion, tiled expansion, and brace expansions are suppressed in this case. However, parameter expansion, arithmetic expansion, and command substitution are still carried out. Using double quotes, we can cope with file names containing embedded spaces. Let's say we were the unfortunate victim of a file called this two words.txt here. If we try to use this on the command line, we are word splitting would line called the two words.txt, and if you try to use this on a command, word splitting will cause this to be treated as the two arguments rather than the desired single argument. So for example, I want to create a new file, for example, touch my file without question mark or something, and here ls, and as you can see, we created my file, which now if we write it like that, for example, ls l my file.txt, this will take as a two arguments, but we, in order to access this my file, we will use double quotes for accessing this here, and as you can see here, we accessed to my file here. So there, and as you can see, now we don't have to keep tying those pesky double quotes. So remember, parameter expansions, arithmetic expansions, and command substitution still take place within the double quotes. For example, look at this. So echo, and here we will do double quotes. So inside this double quotes, we will user and $2 plus 2 plus 2, and after that we will use $, and after that we will call calendar. So this call is actually calendar, which we will show us, and calendar is actually not installed. So let's actually install calendar. So sudo apt install ncal, and I don't think it will take much time because I think it's just here Kali. And here this is just a 69 kilobytes of file size, and it's already installed here. So now let's clear our files, clear, and use previous here, and as you can see here, we got calendar on it on the screen. So we shall take a moment to look at the effect of double quotes on command substitutions. So first, let's look a little deeper at how word splitting works. In earlier lectures, we saw how word splitting appears to remove extra spaces of in our text. For example, this is auxiliary, and here academy, and as you can see here, it just ignored our text. So by default, the word splitting looks for the presence of a space, tabs, and new lines in line feed characters, and treats them as delimiters between words. So this means unquoted space, tabs, and new lines are not considered to be part of the text. So they serve only as separators because they separate the words into different arguments. Our example command, the line, contains a comment followed by 4 distinct arguments. If we add like this, for example, add the quotation marks in the start of the end of the line, and as you can see here, it is not ignoring our new lines or spaces as it did in our previous example. operating systems in the Unix tradition differs from those in the MS-DOS traditions, and in that they are not only multitasking systems but also the multi-user systems. So what exactly does this mean? So if you're asking that it means that more than one person can be using a computer at the same time. So while a typical computer will likely have only one keyboard and monitor and mouse, it can still be used by more than one user. For example, if a computer attached to a network or internet, remote users can log in via SSH secure shell and operate the computer. In fact, remote users can execute graphical applications and have graphical output appear on the remote display. So the X window system supports this as a part of its basic design. The multi-user capability of Linux is not a recent innovation, but rather a feature that is deeply embedded into the design of the operating system. Considering the environment in which the Unix was created, this makes perfect sense. Years ago, before computers were personal, they were large, expensive, and centralized. So a typical university computer system, for example, consists of a large central computer located in one building, and terminals that were located through on the campus. For example, this is our computer, and this is our terminals that is located through our university campus. So each of these nodes connected to the large central computer, which in this case it's our large central computer is this. So to make this practical, a method had to be devised to protect the users from each other, right? So after all, the actions of one user could not be affected. Actions of one user cannot be affected by many users. So here, let's actually draw our person right here. So the action of our one user could not be allowed to crash the computer, nor could one user interface with the files. For example, this is belonging with this username is Max, and this is Carl. So the Carl could not access our Max files, or Max cannot access Carl's files. So that's it. That's it with our user permissions, which you will learn in this section. So to make this practical, you will learn the id command. Actually, let me delete all of this. And so in this lecture, you will learn about the id command in terminal. So this id command we're going to use to display the user identity. You will also learn about the chmod command. So this command will change a file's mode. You will also learn umask, and this umask, we're going to use this umask command to set the default file permission. You will learn about the sudo. The sudo is to execute a command as another user, but su means run a shell as another user. So you will learn about these differences between su and sudo in this section. And also you will learn about 3 terminal commands, which is chown, which this will change the file's owner, and chgrp also this will change a file's group ownership. And we also have actually let me write this right down here. So we will also learn passwd, which with this command you can change a user's password. In next lecture, you will learn about the owners, group members, and everybody else in Kali in general Linux systems. So I'm waiting you in next lecture. When we were exploring the system in previous lectures, we may have encountered a problem when trying to examine a file, for example, such as the shadow files, for example, file and etc shadow, and here as you can see a regular file, no read permission, and you can also here less, we can also here shadow, and as you can see here the permission is denied. So the reason for this error message is that as a regular users we do not have permissions to read this file. In the Unix security model, a user may own files and directories. So when a user owns a file or directory, the user has control over its access. User can in turn belong to a group consisting of one or more users who are given access to files and directories by their owners. In addition to granting access to a group, an owner may also grant some set of access right to everybody. So when which in Unix terms is referred as the world. So to find out information about your identity, you can use the id command, and as you can see here in this case in the output, when user accounts are created, users are assigned a number called id, which is then, for the sake of the humans, mapped to as a username. So the user assigned a group ID here, GID, and may belong to additional groups. So this example is from our Kali system. On other systems such as Fedora or Ubuntu, the output may look different. So as we can see, the user ID and group ID, GID here, actually let me write that down here so some of you can also understand. So user ID means user, UID means user ID, and GID, GID means group ID. Here, so as you can see here, in your system this might be different. For example, in your system it might be the 500 or different numbers. So this is simply because if you are getting different numbers in Fedora starts its numbering of a regular user accounts from 500. So in Fedora it starts from 500, while the Ubuntu and Debian based system, in this case Kali Linux is Debian based, it started from 1000. So we can also see that the Kali Linux user belongs to a lot more groups, and this has to do the way Ubuntu or Debian or Kali Linux manages privileges for system and devices. So where does this information come from? So like so many things in Linux, it comes from a couple of text files. So user accounts are defined in etc passw. Actually, let me write that down here so you can use. So actually let's write clear etc and passw. So all of these accounts are defined in the etc passw file, and the groups are defined in etc obviously group file group. So when a user or user accounts and groups are created, these files are modified. These files are modified along with the etc shadow. So which and actually etc shadow file it holds the information about the user password. So for each user account, for example, etc passw files defines user login name, login name, user ID, for example, in this case, and as you can see, user ID, group ID, account real name, home directory, the login shell, and so on. So if we examine the contents of etc passw file, the user login name or actually etc passw and actually etc passwd, not w here. So here, if we examine this and the etc passw and etc group, we notice that besides the regular user accounts, there are accounts for super user. In this case, super user accounts here, user ID is 0, super user accounts has 0 super ID, and various other system users. So in next lecture, you will learn about the reading, writing, and executing in Linux. So I'm waiting you in next lecture. Reading, writing, and executing. So access rights to files and directories are defined in terms of read access, write access, and execution access. So if you look at the output of the ls command right here, and you will see here l here, so you will see here that we can get some clue as how this is implemented. So in previous lectures, we learned about file attributes, and the first characters is the file type. So the file type describes the file types you are most likely to see, and there are other less common types to do. For example, this here, this means a regular file. This first attribute means here. So let me actually write that down here, and you will see what is going on here. So the minus here means a regular file, and as you can see here, some of examples, for example, my file, my new dear. This might be like my new dear, but the name just my new dear, it's actually a file. And as you can see here, it starts with this attribute. All of the files starts with the regular file starts with this attributes. We also have, notice here that we have a directory here. D is directory, and we also have L. This is a symbol. This is for the symbolic links that we learned earlier. In this case, we don't have symbolic links, and we will create that symbolic link. C here means a character special file. Here, this is character special file, and this file type refers to a device that handles data as a stream of bytes, such as terminal or dev null. And we also have B. The B is for a special file, block special file, and this file types refer to a device that handles data in blocks, such as hard drives or DVD drives. So the remaining 9 characters of the file attributes called the file mode here. Actually, let me write that down here. So D, for example, let's take this, right? Copy this, and here, oops, here, open our notepad, and here. So this was our directory. This is a file type directory, and others are file mode. So these file modes represents the read, write, and execute permissions here. And actually, let me get my marker here so I can show you better. Oops. Okay. So let me here. So this D here. So these are the file mode here. So actually, let me write that down here. So these are file mode, and the first letter represents us that represents us the file type. Yeah, file type. as I explained, whether it's a regular file, directory, symbolic link, or char special file, or block special file here. So, and in order to understand that, here, first lecture, let's make this down right here. So, the remaining 9 characters of file attributes, as I said, is the file mode. So for the files owner, the files group owner, or everybody else. So in this case, for example, it's going to be like this is for, oops, actually, let's here. So 1. It's actually a little more easier to understand right here. So as I said, this is file type, and all of these are file permission attributes. But here, the first three means owner permissions. The next 3 means the group permissions, which you will learn all of this about in this section. And the last means the world, the everybody else. So the R means read. The W means execute. Oops, not execute. The W means write. And here, X here means execute. So now let's explain all of this now. So the R here, the R allows a file to be opened and read. So if this R, you can see this R in a files, for example, in this case, this, yeah, right, R, this means allows a file to be opened and read. But if you see this R in directories, this allows a directory contents to be listed if the execute attribute is also set. We also have W, as you learned here. So the W allows a file to be written or truncated. However, this attribute does not allow files to be renamed or deleted. The ability to delete or rename files is determined by directory attributes. And if you see this W attribute in a directory, this in that directory allows a files within a directory to be created, deleted, and renamed here. So here, first one we learned about the file with this W, and now, so if you open this, if you use this in directories, you will gain an access to create, delete, and renamed, and if the execute arbitrary is set, or actually there. So we also have, let me write here. Oops, yeah, right. That's actually, we also have the X here, actually. Let's delete all of this. So the X, just an X. So this X allows a file to bring to, and by the way, if you use this X in a file allows a file to create a program as a treat as a program and execute it. So program files written in scripting languages must also be set as a readable to be executed. And here, if you use this X in directories, this will allow a directory to be entered. For example, cd my dir. So if you use that in directory, X in directory, you can enter and in that directory here. Hello, my name is Stefan. Welcome to another lecture of our Excel course. In this lecture, you will learn about the permission attribute examples. So let's get started with a regular file that is readable, writable, and executable by the file's owner, and no one else has any access. So in this case, as you remember, the file starts with this attribute, and after that we will r wx, and then here 333 and 333. Here, that's it. This with files that has this permission is a regular file, is readable, writable, and executable by the file's owner, only the file's owner, and no one else, no group, no everyone has any access. So here, actually, yeah, here. So now let's create another here. So this is a regular file, as this implies. After that, rw here. That's it. So guess what it is? So this is a regular file that is readable and writable by the file's owner, but no one else has any access. So in previous, we also had this executable, which we can execute, but in this case we cannot execute, but we can only read and write onto this file. So let's create another example here. So this is also a regular file, rw with read and file by the owner, and read by the group, and also read by the everyone else. So this is a regular file that is readable and writable by the file's owner. Regular file as this, readable and writable by file's owner. Members of the file's owner may read the file, and the file is also word readable. So let's actually create another text test here. So this is also a regular file, rw and rw here, and that's it. So as with previous examples, this is also regular file that is readable and writable by file's owner and the members of the file. So it's also the readable and writable for members of the file group only, and not everyone else cannot access this file. So let's create another example now. Let's create a symbolic link, right? Or let's first create two directories, and lastly create symbolic link for us. That's it here. So let's create directory. So D, as you learned in previous lecture, D means that it's a directory. So let's actually rwx, and not everyone else. So this is a directory. The owner and the member of the owner group may enter the directory, create, rename, and remove files within the directory, but no everyone else does not have access to it. So let's create another directory example here. So D, this is a directory, rwx, and after that, actually, yeah, rx, and here. So that's it. As the name implies, the first attribute is a directory, and the owner may enter the directory, create, rename, and delete files within the directory, and members of the owner group may enter the directory but cannot create, delete, or rename files. So they the rename files. So they enter, but as the W here implies, they cannot create, delete, or rename files, and everyone else cannot has access to it. You may be wondering about where these file permissions came from. So the answer is umask. So the umask command sets the default permissions for any file or directory you create. So for example, touch my new file, and here we're gonna see here lsal and new file here. Oops, not my new file. So here, as you can see here, the touch command created the file using the default permissions assigned to my user account. As you can see here, that's it. The umask command sets the default permission. So unfortunately, the umask command setting isn't overtly clear. So, and trying to understand exactly how it works make things even muddier and hard to understand. So the first digit represents a special security feature assigned to a file umask here. As you can see, in my case, it's 022. And probably you will have that number too, or 022 or 00222. So we will talk more about that later in this course. And the first, let's get started with understanding our file permissions. So the next 3 digits represents the octal values of the umask for a file or directory. So to understand how umask works, you first need to understand the octal mode security settings. So octal mode security settings take the 3 RAAX permission values and convert them into a 3-bit binary value represented by a single octet value in this permission here. So in the binary representation, each position is a binary bit. So if the read permission is the only permission set, the value becomes is going to R minus R null here. So relating to the binary value of 1, 0, 0. So indicating the octal value 4. That's it. And you will learn all of this in this lecture. So let's get started with our representation of file permission codes in Linux. So permissions, firstly we're gonna write it permissions, binary, and here we're gonna have octal, and lastly the description. And here in permission, for example, if we don't have a permission here, then we're gonna in binary we're gonna have 0, 0, 0, and in octal we will also have 0, and it's gonna description is gonna be no permission. So actually I will share this file after completing it. So you will need this file after some time in assigning the permissions in files or folders. So this has no permissions at all. So permissions here, and we will also have the null x here, which is going to be 0, 0, 1 and 1, and it's going to be, as you remember in previous lecture, what's going to be, it's going to be executable, and here execute only, execute only permission. And we can also have the write only permission here. You have learned this in previous lectures. So 0, 1, 0, and it's going to be 2, and it's going to be write only permission. And here we will also have 0x. Guess what it is? 0, 1, 1, and it's going to be 3, which, remember, yeah, it's going to be write and execute permission. And here we also have our minus, and it's going to be, guess what, 100. And here we're going to have 4, and as the name implies, and you learned in previous lecture, it's going to be read only permission. We can also have our x, which is going to be 1. Guess what? 0, 1. And here we're going to have octal 5, and it's going to be read and execute. And here we will have, what will that? R and W. And guess what it is? Here 1, 1, 0, and here we have an octal number of 6, and it's going to be, guess what? The read and write permission. And lastly RWX, which is gonna be 1, 1, 1, and 7, which is gonna be, this will have all the permissions it has. So read, write, and execute permission. So octal mode takes the octal permissions and lists 3 of them in order to in order for the three security levels, user, group, and everyone. So use the octal mode value here represents 6, 6, 9, 664. Which is represents the read and write permissions for the user. Actually, let me write that nicer here. So in this case, 6, 6, and 4. So the 6 here, remember, the 6 here represents read and write permissions for the user. So as you remember in previous lectures, the first is user, group, and everyone else. So here the 6 for user, and it's going to be read and write permissions to user, and for the group, this is the same for the group here. So same for the group. The group also has the read and write permissions, and the 4 is everyone else, which is everyone else can only read this file and not write, delete, or execute it. So that's it. So now that you know about the octal mode permissions, the umask value becomes even more confusing. So the octal mode here, actually, let me write that down here. Yeah, the octal mode shown for the default umask on my Linux system is 022. In your system it might be 0022, so it's all the same actually. So but the file I created, I had an octal permission of 644. So how did that happen? So here actually LSLA. So oops, let's clear by meaning that 644. I just want to show you here. So let's actually copy this. Yeah, and here, as you can see here, this means our file is file, the regular file. And here, let's actually make it a bit look nicer. We don't need this information now. And here, so let's turn this into binary and octal number. So turning this into binary and octal number. So here it's going to be 0. Actually, we don't need that either. See, this is just a file representation that it's file or symbolic length. So you learned that. Actually, you learned that in previous lecture. If you don't remember, just go back to previous lecture and come back here later. So here, RW, remember, RW 6, right? 6. Actually, yeah, 6. R null is going to be 4 and 4 here. And here we would also have, in the binary representation, is going to be RW is going to be 110, 1 here, 110, and 110 here. That's it, right? It's actually not that complicated, right? So, but here, 0 to 2, here, you will understand all of this here. So the umask value is just the mask. So it masks out the permissions you don't want to give to the security level. So now we have to dive into some octal arithmetic to figure out the rest of the story. So the umask value is subtracted from the full permission set from an object. So the full permission here is 7, 7, right? So the full permission is 777, right? Actually, let's yeah, we can also use this arrow to look it nicer like this. And here, that's it. It looked nicer, right? So the full permission is 777, right? So, and actually, and read and write permission, we also have the full permission. I'd say it's kind of full permission here, but 666 is the read write permission for all. But for directories is 777, which is read, write, and execute permission for all. To use in this example, the file starts out with a permission 666. The starts with 666, which is read and write permissions for all. Read and write permissions for all. So let's actually mention that down here. 666. So which is read and write permissions for all. But for directories, it's 777. Starts file. For file, it's 666. And for directories, starts with directories. It's what I said, the 777. Here. That's it. So, use in this example, the file starts out. So, as you remember, we created a file, right? My new file. So, the file starts with a 666 and the umask 022 is applied. So, leaving a permission 644. So, you will now understand all of this. So, 666, right? This starts with the file. And if we apply 022, we need to subtract that 022 from 666, and it's going to be what? The 644. And that's all the logic with our umask file. And here, as you can see, 644. And we can also do, for example, let's change our umask file. For example, umask 026. And here, you can also actually, the umask value is normally set in the etc profile, cat etc profile, and oops, cat here. I will just read here, and as you can see here, the umask value is usually set in the etc profile startup file here. And you will learn about this file in later lectures. You can specify the different default umask settings using the umask command. So for example, umask 026, and let's check the umask now. Umask and touch new file 2 ls, and here here lsla my file, my file, new file 2, and here, as you can see, let's actually copy that down here and see what changed. It's actually something changed, right? Right here. Let's copy this, paste it here. So in this case, actually, let's actually mention it that our default def here, mask when we executed this command and created this file, our mask was 022, right? As you remember. And here, so our double 1 2 3 and 1 2 3. Here. So in this case, when we created this file, our umask number was what was it? 026. And you will now understand it more deeper here. So RW, what was it? 6, right? So 6 is 110, and then R minus minus. Our null is 4, right? 1 0 0, and lastly we have no permission at all, and here it will have what? 0 0 0. And in this case, our default file permission is going to be what? Yeah, I'm waiting for you. 3 2 1. It's going to be 110 6 100 4 and 0 and 0. That's it. That's as easy as that. So now let's actually this examples was all executed on a files, and let's try with the directories here, right? As you remember, files and directories default permission, the full permission is different. So file is 666 and for directory is 777. So when we set the umask value to 026, the default file permissions become 640. This is for file. So the new file is now restricted to read only for the group members, and everyone else on the system has no permissions to the file. So the umask command also applies for making new directories here. So umask make dir, oops, not umask here, ll clear. So make dir my new directory, or my new dir, it's okay, and ls l my new dir, oops, ls l la here. Don't we have my new directory here? Oops, sorry. My new file, my dir, my new. Yeah, as you can see, this is our my dir, and let's copy that out and see what actually happened here for dirs or examples. Here, so let's so this d here, I will explain all of this right now. So this here, d here, as you remember in previous lectures, this d means that it's a directory, so we don't need that. We already know that it's the directory. So rwx, remember 7, right? So mask was for 026. Again, let's check the mask. Clear umask, and that's it's a 026 here, 026, and the mask is going to be 026 here, as you can see here, the 026, and it's gonna, so rw7 rw6 rwx is gonna be 7, which is 111, then rx 101 and 00x here, just the 1, so 001, and let's turn that into octal. 111 is 7, 5 and 0. Yeah, that's it. As you can see here, because a default permission for a, and this, as you can see, these are the complete different numbers, right? And you will understand now. So because the default permissions for a directory are 777 and the resulting permission from the umask are different from those of a new file, the 0026 umask value is subtracted from the 777, leaving the 7. Actually, it was not 1 here, so sorry for that. It's 1. So the directory permission setting here. Actually, let's prove that. So here, now we're gonna 777, and after that we're gonna enter 026, and here we would have 7, 5 and 1. It's proven. If you have already created a file or directory and needed to change the security settings on it, a few different utilities for this purpose are available in Linux. This section and this whole lecture, you will learn how to change the existing permission, the default owner, and the default group settings for a file or directory. So my name is Tayfun. Welcome to another lecture of our study course. Let's get started. The chmod command allows you to change the security settings for files and directories. The command chmod here. So the command format is like this. So firstly, you're gonna enter the chmod, then options came here. Actually, let's use the marker here. So firstly, you need to enter the chmod, and after that, after chmod, you will operate the options, and after that, you will enter the mode, and after lastly is file that you want to change the comments and permissions on it. So in order to do that, the mode parameter here the mode parameter allows you to set the security settings for either octal or symbolic mode. So the octal mode settings are pretty strict format. So just use the standard 3-digit octal code that you learned in previous lecture. Remember this here? Yeah, remember this. This is the permissions and their descriptions in binary and octal. So if you want to make something like let's create actually new file, and touch my new file. We already have my new file, or let's actually my ultra new file. Yeah, my ultra new file, and here let's actually lsla my ultra new file, and as you can see, this is following permissions right now, right? Actually, let's open a new here and copy this and make examples from it here. As you can see here, we have this. This is just, we will ignore it. You learned actually this in previous lecture, that this is a file types. So in this case, it's just a regular file. So we will ignore it and we will copy this. We will ignore the first character. Copy this. Actually, let's go here. So now that's it. Now I will show you right here. So as you can see here, RW is 110. Then here R minus minus, R null here 100 and 100 again. So after that, in octal actually we are seeing the 6 0 0. So the permission for this file is my ultra file is this, right, in octal, and here in permission here. So as I said, the mode parameter allows you to set the security settings using either octal or a symbolic mode. So in order to change this here, for example, chmod 6, let's actually use 760, and here let's see what this 760 is. So 7 is RWX, then it comes 6 RW, and after that 0 is 000, and that's it. And so let's see what is this in a binary. So 111 RW is 110 and 000, right? Yeah, here, and after that it is 760, and this is going to be my ultra file, the new my ultra file permission, and just new permission here. Now let's use this chmod, then your permission, and then file or directory name. In this case, my ultra new file. And here let's run it again, and that's it. As you can see here, we got the desired result here. So let's see, let's compare these results here. As you can see here, these are exactly the same result. So this table will help you in order to use that. So the octal file permissions are automatically applied to the file indicator. So the symbolic mode permissions are not so easy to implement. So instead of using the normal string of 3 sets of 3 characters, the chmod command takes a different approach. So in order to do that, here. So in this ch mode, firstly you're gonna enter ch mode and then ugua here. Yeah. This doesn't make sense, but you will understand here. So ugua here, and after that plus, minus, or equal, you will enter one of these characters, and after that you have this rwx uppercases stugo. So you will enter one of these here. This doesn't make perfectly good sense, right? So the first group of characters defines to whom the new permissions to apply. Actually, ugo a not like that. St ugo, and here we're gonna have the ugo a, right? User group o a here, and so on. You will have different groups here. So the first group of characters defines to whom the new permission to apply. In this case, u is, oops, yeah. In this case, actually, sorry for this. So let's copy this so you can see better here. So in this case, the u for user, the g for group, and o for others or everyone else, and a for all of this group here. So this will assign to a. So the next symbol is used to indicate whether you want to add the permission to the existing permission with plus, subtract the permission from the existing permission from minus, or set the permission to the value. Finally, the third symbol is the permission used for setting. So you may notice that there are more than the normal RWX values here. So the additional settings are here. So actually, let me write that down here. So here, the S for set, S is for set SUID or SGID on execution. And here we are, T is for setting sticky bit, set sticky bit, which I will explain all of this here. U is to set permissions to the owner's permission. The G here, the G is to set the permissions, permissions to the group's permission. And yeah, STUG, and lastly O here is used for to set permissions to others permission. So here the use for permissions would like this. So chmod o plus r my ultra new file. And let's actually try it again. And here, as you can see here, we got different results from here. So let's actually see what happened. And this is the actually here the test 1, test 2, and this is test 3 here. So RW, actually it's not permission, yeah, 1 2 3, and that's it. So here, as you remember, RWX is 111, 110, and 100. Oops, 110 and 100, and here we will have for this 111, 100. So 7, and actually it's the first is 7, and then it comes the 6, and lastly 100 is 4, and not here. Sorry for this. This is 644, and 7 6, and lastly 4 7 6 4. So the here, as you remember here, the O plus R entry adds the read permission to whatever permission the everyone security level already had. So the u minus x entry removes the execute permissions that the user already had. So in order to do that, let's actually do this. chmod u minus x, and here after that we will use the my ultra new file and ls la my ultra new file. And as you can see here, we just changed that. Let's try that now. So this one was our my ultra new my ultra file. We already made it wrong here. Test3. Actually, my ultra new file, and lastly new file. And here we will have this. Let's do it first. And here 1, 2, 3. And actually the second parameters are same, but the first we changed, we took the execute permissions from it. Let's actually try it now. RW was 110. RW, and again RW was 110, and lastly R was 100, which is 664. And this was our actually let's test again. Is it 110 6 6 664? Yeah, that's true. Ultra new file, and this is test4. And that's it with our lecture, I hope. And I will also share this files with you. So I'm waiting you next lecture.